So, welcome to the next topic of payment engineering. Today, we are seeing about the stabilization of payment as a unit 5. In that unit 5, a lot of topic which covers the stabilization of payment. The first one is stabilization with the special reference book to the highway payment and choice of some various stabilization. In that various stabilization, we will control the testing and field control and stabilization for rural roads in India. And also we are seeing about the use of geosynthetic roads in payment. So the next one is we are seeing about the methods of soil stabilization. So based on the methods of soil stabilization, the first one is mechanical stabilization, and second one is chemical stabilization, third one is polymer stabilization, and final one is stabilization using geotextiles. The first, the soil stabilization in a road construction. Earthwork is used in practically every road building project and nearly every asphalt roads stabilization and repair projects. And soil, whether in the form of undistributed subgrade materials, transported and reworked base or embankment materials, is foundation materials for the all roads and highways. Clay softness and liquefies when exposed to a large amount of water, and this feature makes construction problematic due to the low strength and stiffness. Finally, this cause significant geotechnical engineering issues as weak soil can undetermined land stabilization and building foundation while producing fisheries in building and also the asphalt pavement road surfaces. What are the materials we are using in the soil stabilization for the loose soil in pavement design? The first one is it will contain the different grades in soil. The second one is different grades of aggregate. Third one is seedlings. And fourth one is seeds. And next one is hydro mulch mixtures and hydro seeding mixtures and geomaterials that is used in geogrids and geo blankets. And finally, the polymers we are using synthetic material and also the natural and synthetic resins we are using emulsions, cement, lime, fly ash, bitumen. Finally, recycled and waste products for the solid municipal waste and also mining industrial waste. These are the some uh, materials we are using in the soil stabilization. So in that soil stabilization, we are using various number of testers and also field control measures. So in that testing, CBR, that is California bearing ratio, that is primarily taken to provide data for road pavement design. It was first developed by California State, that California State Highway Department, so that the California bearing ratio in the name of this test. It is a penetrations test which is used to evaluate a subgrade strength primarily of roads, pavement, foundations. So the CBR test is used as strength test which to determine the thickness of the materials needed for the proposed road construction. Finally, the California bearing ratio, that is CBR, test is a measure to resistance of a material to penetration of a standard plugger under controlled density and moisture condition. Finally, it was developed by the California Division of Highway as method of classifying and evaluating soil subgrade base materials for the flexible pavement. So the next topic is skid resistance. This one is a very important topic based on the skid resistance. If you are driving in a flexible pavement, the skid resistance is the utmost important factors while considering the design of flexible pavement as well as the rigid pavement. In the skid resistance is the force developed when a tire pressure is prevented from the rotating slides along the pavement surface. Skid resistance is an important parameter of pavement evolution because of the following factor. In a inadequate skid resistance, will lead to high accident rate. Finally, the skid resistance measurement can be used to evaluate various types of materials and construction practices. The skid resistance depends on the texture of the pavement surfaces. Example, micro texture and also macro texture. While using micro texture refers to the small scale texture of the pavement. In that skid resistance, we are using aggregate component which control the contact between the tire rubber and the pavement surface. Macro texture refers to the large scale texture of the pavement as a whole due to the aggregate practical arrangement which controls the escape of water under the tire and hence the skid resistance reduced due to increases speed. The skid resistance change over time. Typically, it increases in the first 2 years after the construction. As the roadway is worn away by the traffic and the rough aggregate surfaces become exposed, then decreases over the remaining pavement. The life of a aggregates become more polished. Skid resistance is the also typically higher in the fall of winters and lower in the springs and summer. The measurement of the skid resistance. Skid resistance is generally expressed in the term of frictional measurement, such as function factor or skid number. Friction factor like coefficient of friction F equal to F by L. Skid resistance number Sn equal to 00 F, where F is the frictional resistance to motion in the plane of interface. L is a load perpendicular to interface. It is not correct that a pavement has certain friction factor because friction involves two factors, the tires and the pavement. These factors are variable due to the pavement witness, vehicle speed, temperature, tire wear, tire type, etc. This typical functions testers specify the standard tires and environmental conditions to overcome this. In general, the frictional resistance of the most dry pavements is relatively high. Wet pavements are the problem. The number of accidents on wet pavement is twice as high as a dry pavements, but other factors such as visibility are involved in addition to the skid resistance. The typical skid resistance number, that is skid resistance, that is less than 30 means it will take measures to correct. Greater than 30, that is acceptable for low volume roads. 31 to 34 is monitor payment frequently, and greater than 35 acceptable for heavily traveled roads. So finally, today we are seeing about the a lot of topics. So in that lot of topics, we are summarizing about the methods of stabilization, soil stabilization roads in construction, and what are the materials we are using in the soil stabilization, and finally testing and field control. So in the testing field control, we seeing about the another topic of skid resistance and what are the skid number while using the uh, design of skid resistance. So thank you to all.